So chapter 7.3 for Algebra 2 starts off with the definition of like radicals. Like radicals is when a radical expressions that have the same index and the same radicand. An index, if you remember correctly, gives the degree of the root, while a radicand is the number under the radical sign. So there is your example for both. So this would be the cube root of 2. When adding or subtracting radicals, like radicals must be present. Complete the operation shown, and the result will still include the like radical. So some examples. If we had 2 square roots of 7 plus 3 square roots of 7, we have like radicals present with the square root 7s. So we carry down the like radicals, so square root 7, and with the 2 plus 3 we can perform the operation shown. So with that addition going on between the 2 and the 3, it gives us 5 square roots of 7. Second example. We have the square root of xy and both times, so we carry it down. We have the 4 minus 6, which is then negative 2, so we have negative 2 square roots of xy. Third example. We have 7 cube roots of 5 plus 10 cube roots of 5 minus 2 cube roots of 5. All of those radicals are like radicals. So we carry down the 3 roots 5. 7 plus 10 is 17, minus 2 is 15. So it's 15 cube roots of 5. Now, if we do not have like radicals, which is the case here, we do have like radicands, but different indexes, we would go ahead and say that we cannot combine these. That would be your answer. Now, sometimes you may have to simplify before you add or subtract. If like radicals are not present, attempt to simplify. So for example, if they give you a 6 square roots of 18 plus 4 square roots of 18 minus 3 square roots of 72, what we must do first is simplify each radicand. So let's start with the 18. With 18, I'm going to break it down to a 9 and 2. The 9 can then be broken down into a 3 and 3. So what I'm going to do is I'm going to circle my pairs of numbers. So in this case it's the 3's. What gets circled, so the pairs, gets brought out in front of the radicals. If there's already a number there, you multiply them together. So since I'm bringing the 3's out, I already had a 6 there. So 3 times 6 would be 18. And then what's not circled or broken down gets put back underneath the radical. So it'd be 18 square roots of 2. With the 8, I'm going to break it down to 4 and 2. Break down the 4 into 2 and 2. Circle a pair of 2's. 2 gets brought out, gets multiplied by the 8. So it's plus 8 square roots of 2. The 72, I'm going to break it down into a 9 and 8. 9 breaks down into a 3 and 3. The 8 breaks down into the 2 and 4. 4 breaks down into a 2 and 2. So I have two different things of pairs here. So I'm going to multiply them together. So 3 times a 2 is a 6. That 6 gets multiplied by that 3, or that negative 3. So that's a negative 18. And then we have square roots of 2. So we have the 18 square roots of 2 plus 8 square roots of 2 minus 18 square roots of 2. Whenever all those have the like radicals, so therefore whenever you have the 18 plus 8 minus 18, it ends up giving you 8 square roots of 2. If we have 3 cube roots of 81 minus 2 cube roots of 54, I'm going to break down the 81 first. I'm going to break it down into a 9 and 9. And then each pair of 9 there, I'm going to break down into 3 and 3. Since this is cube roots, we're no longer looking for pairs, we're looking for triplets. So we have 3 3s that we can circle. That triplet gets brought out in front and gets multiplied by the 3 already there. So 3 times 3 is a 9. And then cube roots of 3. So it's not circled, gets multiplied back together and brought underneath, but it's just the 3 there. As for the 54, I'm going to break it down into 9 and 6. 9 breaks down to 3 and 3. 6 breaks down to a 3 and 2. I have a triplet there that I can circle. So a pair of 3's times the negative 2 is a negative 6. Cube roots of 2. And then we will leave that as our answer since they are not like radicals. So that is how we simplified that problem. Next, we need to talk about multiplying binomial radical expressions. Same rules as multiplying radicals, just use the FOIL method. So for example, if I had a 3 plus 2 square roots of 5 in one quantity times the quantity of 2 plus 4 square roots of 5, what I must do is still use the FOIL method. So F in FOIL stands for the first terms. So that's going to be a 3 times the 2. 3 times 2 is 6. The O stands for the outer terms. That would be the 3 and the 4 square roots of 5. 3 times 4 square roots of 5 is 12 square roots of 5. The I stands for the inside terms. So 2 square roots of 5 times 2 would be 4 square roots of 5. And then L stands for the last terms. That's 2 square roots of 5 times 4 square roots of 5, which is 8 square roots of 25. Now, I'm going to go ahead and start simplifying and adding or combining like terms, or I'm sorry, not terms, but radicals. So I'm going to carry down my 6 plus 2 square roots of 5 plus 4 square roots of 5 ends up being 16 square roots of 5. Now, square root of 25 is 5, so 8 times 5 ends up giving you a 40. I can go ahead and combine the 6 and the 40, making 46 plus 16 square roots of 5 is my final answer. So let's look at another example of this. If I have the square root of 2 minus the square root of 3 squared, I'm just going to rewrite it where I can use the FOIL method. So the first thing that I'm going to do is square root 2 times the square root of 2. That gives me a square root of 4. Square root of 2 times a negative square root of 3 is a negative square root of 6. Negative square root of 3 times a square root of 2 is going to be a negative square root of 6 again. And then a negative square root of 3 times a negative square root of 3 is a positive square root of 9. Simplify what I can, and then combine what I can. So the square root of 4 is 2. A negative square root of 6 minus the square root of 6 is a negative 2 square roots of 6. The square root of 9 is 3. Now we can combine 2 plus 3, which gives us 5. And then we carry down the minus 2 square roots of 6 to give us our final answer of 5 minus 2 square roots of 6. Now, we need to talk about conjugates a little bit. A conjugate is expressions that differ only in the sign of the second terms. So, for example, it would be square root of a plus the square root of b in one quantity. The second quantity would be square root of a minus the square root of b. So the only difference is that plus and the minus in between both terms. Whenever we have this, I would not FOIL. I would use the shortcut that I'm about to tell you about. Whenever you would do this, you would just square each term. So with that square root of a, I would square it, and then I'd have minus the square root of b squared, which ends up just being a minus b. So, for example, if I had the quantity 2 plus the square root of 3 times the quantity 2 minus the square root of 3, I notice that that's a conjugate. So I take the first term of 2 for both of them. I take 2 and square it. I put a minus. And then I take the square root of 3 and square it. Now 2 squared is 4. Square root of 3 squared, they cancel each other out to leave it just as 3. So 4 minus 3. 4 minus 3 is then just 1. Now, whenever we are dividing binomial expressions, we need to make sure that we rationalize the denominator. So, for example, if we had a 6 plus the square root of 15 divided by 4 minus the square root of 15, what we have to do to rationalize is we must multiply both top and bottom by the conjugate of the denominator. So with the denominator being 4 minus the square root of 15, we have to multiply both top and bottom by 4 plus square root of 15. Okay? So we still have to use the FOIL method for all of this. So for the first, or the top, we're going to go 6 times 4, which ends up being a 24. 6 times the square root of 15, which is 6 square roots of 15. We then have the square root of 15 times 4, which ends up being a positive 4 square roots of 15. And then the square root of 15 times the square root of 15 is the square root of 225, which here in a little bit we will simplify. Now all of this is over. We still have to FOIL the denominators. 4 times 4 is 16. 4 times a square root of 15 is 4 square roots of 15. And then a negative square root of 15 times 4. We have the negative square root of 15 times a 4, which ends up being a negative 4 square roots of 15. Then the negative square root of 15 times a positive square root of 15 is a negative square root of 225. Now let's go ahead and start simplifying what we can. With the 24, we carry it down for now. The 6 square roots of 15 plus 4 square roots of 15 ends up being 10 square roots of 15, plus the square root of 225 is 15. All that is over. Carry down the 16. 4 square roots of 15 minus 4 square roots of 15 makes it 0, so we don't have to put anything. Minus 15, because the square root of 225. Now let's simplify this even farther. 24 plus 15 is 29. I'm sorry, 39. Got to carry down, or carry the plus 10 square roots of 15. And then that would be our answer because it's all over 1. If you have any questions, please come see one of the math teachers.